Today we are starting up a lecture series on wire rope slings. And in this wire rope sling lectures, we will not only understand the empirical relation to calculate WLL, but we will go into deep understanding the concept, understanding the science behind the wire rope sling. Okay, so let's start our lecture. Now these wire rope slings are basically used having two major application. First is lifting and rigging. Whenever we want to lift something, then the rigging arrangement is being done using the wire rope sling. Apart from that, it is used for hoisting operation in winch, in cranes, etc. Okay, these are basically the two major application of the wire rope slings. Now if you are lifting something, then the main property come into picture. If something is lifting up, then the arrangement that you are lifting up, if you are lifting something to a wire or a rope, then wire will be under tension. The first important property of a wire rope sling is tensile strength. Okay, it is clear that it must have a very high tensile strength. The second important property is bending and torsional stiffness. Now we will understand how this is a very important property, because these wire rope slings has to be used in cranes, and in the crane, if you want to increase the number of falls, then these wire rope sling have to be passed through the sieves. Okay, the second is, if you are using it in the winch machine operation, then this wire rope sling has to be wrap around a drum. Okay, so these are basically the important aspects of the wire rope sling. That is, it is very flexible. It can easily wrap around a drum, or it can easily pass through the sieve, etc. So the second important property is bending and torsional stiffness. That is basically flexibility. If something is having higher bending and torsional stiffness, then it will not be easily flexible. It can't be bent around something. Okay, so the two most important properties are tensile strength and bending and torsional stiffness. So based on application, wire rope sling always have tensile strength high, but depending on where you are using up, we have to focus on the bending and torsional stiffness also. And generally wire rope sling have low bending and torsional resistance. How this low bending and torsional resistance come into picture, we will understand later in this video. Okay, so now if you are using a simple single rope, if you are lifting something to a single rope, as the diameter of the rope increases, the tensile strength obviously increases, but the flexibility reduces. Okay, it will be more having more resistance, having more bending and torsional stiffness. So there is a construction of the wire rope sling. So we have to basically design wire rope sling in a different manner. So now comes into picture the construction of the wire rope slings. If we see this, this is the cross section of the wire rope slings. So it is having a center wire. Okay, there are basically a center wire or the core. Around this center wire, multiple strands are twisted, and together form a wire rope sling. So this is the basic idea. Here there is a one center wire over there. These are basically called as the smaller circles. These are called as strands. Okay, so if we go more into deep, so this is the core, this is the center core of the wire. Okay, around the core, number of multiple strands are twisted, okay, in a particular arrangement. We will understand about that arrangement also. And now these strands, how these strands are formed? These strands are formed like this, the wire rope sling. These strands are also having a central wire, and this center wire, a number of wires are being twisted. Multiple wires are being twisted. So how it is having a construction? First of all, V is having a single wire. This single wire is twisted around a central wire to form a strand, and these strands are twisted around a core to form wire rope sling basically. Okay, now how these construction affect the properties? So now what happens basically, if you go into the deep, what happens, as these are number of wires, if we are using a single wire and if you are using a number of multiple, as you are seeing it, suppose there is a 1 into 17 construction. Okay, and you are having another construction like this, 7 into 19 construction. So number of wires in 7 into 19 is basically 133 wires. Okay, so now these 133 wires are together, or suppose in this case, number of strands, there are number of wires in strands, and there are number of wires in stand. So these all wires together are taking up the load. So what happens, the aggregate effect of multiple strands sharing the load increase the tensile strength. So in this manner, high tensile strength is achieved. Now the second question is how we are able to achieve low bending and torsional resistance using this construction. Now, what happens basically from the wire rope construction, as many small wires with frictional contacts are there. Okay, in it, there is a center wire. In center wire around this, there are a number of wires twisting another twisting each other. So basically, what happens? There is a number of many small wires with frictional contact, which allows slippage and deformation. Okay, when some bending and twisting is produced, then apart from acting as single body, they basically acting as a separate body, and there is basically frictional contact is there, and there is slippage and deformation. So what happens? Whatever the bending load is coming up, it is not getting fully, it is basically the partially is compensated between the slippage, compensated between the friction or slippage. So in this manner, it has very low bending and tensile, bending and torsional resistance. So you understand. So what happened? The aggregate effect of number of wires together increase the tensile strength, and due to frictional contact and the slippage between the wires, it is not acting as single body. There is having low twisting and bending forces. Okay, okay. So this is clear up to now. This construction also affects the property of the wire rope sling. Basically, the wire rope sling construction affects the tensile strength of the wire rope sling. Factors. First factor of the wire rope sling that affect the tensile strength: the number of strands and wire, number of strands and wire per strand. Basically, if you are it is a simple case. Suppose there is a wire rope sling having 1 into 19. Okay, and the other is 7 into 19. Okay, so this 1 into 19 arrangement is having less wire, this 7 into 19 arrangement is having more wire. Now this more wire and less wire, what happens? This 1 into 19, if you are using a wire rope sling of the same diameter, suppose, okay, there is a one wire rope sling 1 into 19, and there is a other wire rope sling 7 into 19, and there is basically 25 wire rope sling you are being using up. So the diameter is same, both having the same diameter, but here the number of wire ropes that are present is 133 wire ropes. Here number of wire ropes, or basically the number of wire present are 19. Here the number of wire present is 19, here the number of wires present is 133. The diameter is same, and here the diameter is same, but the number of wires present over is 133, here is 119. This means that the diameter of these 133 wire will be thinner. These 133 wire will be thinner. Okay, so these 19 wire will be thicker. So this having 1 into 90 configuration is having much higher tensile strength, but it will not be more flexible, because here the number of wires are 19 only, combined total wires are 19 only, but here it is having a tensile strength, okay, tensile strength, not that much higher as compared to 1 into 19 construction, but here the number of wires are more, there will be more friction, there will be more slippage. So this 7 into 19 will offer a lower bending and torsional resistance. Okay, so it is where there is application related to the flexibility, where this wire rope has to be wrap around a sieve, or has to be wrap around a drum, then this wire rope sling 7 into 19 is more useful. Understand? If the number of wires in a construction increases, number of total wires increases, this means that the flexibility increases, and such wire rope slings is to be used in where like drum operations, like winch we have to use that wire rope sling in the crane hoisting operation, because they are more flexible. Okay. The second thing is arrangement and lay of wire. I already show you how these arrangement affect the strength and flexibility. Wire material quality and grade, this also affects. हाई कार्बन स्टील होता है, स्टेनलेस स्टील गेट्स हैं, ठीक है, these basically impact tensile strength को affect करते हैं. High grade steel wire yields higher tensile strength. Now dia, I also show you how this dia affect the number of wires. If you are keeping the dia same, large dia means more tensile strength, and having the same dia but large number of wire means have more flexibility. And the second thing is material. Okay, so these are the main property that is affecting the tensile strength of the wire rope slings. Okay, if you are going will share you another example. This 1 is to 19 construction is there, 7 into 7 construction is there, 7 into 19 is there. If we talk about this 1 into 19 construction, This 1 into 19 construction, there are 19 wires, and this 7 into 19 construction is having 133 wires. This 1 into 19 construction has 15 to 40%, 15 to 40% higher tensile strength as compared to 7 into 19. Okay, but this 7 into 19 provides better flexibility, but trade off some tensile strength. So basically, selection of the wire rope slings depends upon the application requirement, balancing strength and flexibility. Hope you like this lecture. Keep supporting, subscribe. In the next lecture, we will understand more technical aspects of wire rope slings. Stay tuned and subscribe.